All right, so 1.5 is use a problem-solving plan. So these are basically like short word problems, more or less. So just the steps that go with this. Step 1 is to read and understand the problem. So that we know what the goal is, what we're trying to solve for, and all that. Step 2 is to make a plan in order to be able to solve the problem. Then, based on that, step 3 is to solve the problem. And if it happens to not work, if that method doesn't work, then try something else, okay? Try a different way to solve it or whatever. And then step 4, check to make sure your answer is reasonable. All right, and then we have a few just important formulas to be aware of that we'll use when solving these problems. We have one for temperature, which is C equals 5/9 times F minus 32, where F is degrees Fahrenheit. And C is degrees Celsius. Then we have simple interest. And this one says I equals P times R times T, where I is interest, P is the principal, which this is just the starting amount of money. Then we have R is the interest rate. As a decimal. A lot of times it gives it to you as a percent, so you just have to move the decimal place left 2 spots to get the decimal from the percent. And then lastly, we have time, or T, which is time. And most of the time, that's in years. And then we have distance traveled. Which is D equals RT, where D is distance traveled. R is the rate, which is just the speed. Okay. Most often in here, it's going to be miles per hour. On occasion, it might be like miles per minute or something, but that's fine. And then T is time again. And the time's going to be whatever the, like, miles per hour, then the, like, time would be in hours. If it's miles per minute, time would be in minutes. So it's just dependent there. And then the last formula is for profit. And that's just that P is equal to I minus E, where P is equal to, or P is profit. I is income, and E is expenses. All right, so some examples. These problems, they kind of do a little bit with like different steps. This is actually kind of a short section. But at the beginning, they say in exercises 3 through 5, identify what you know and what you need to find out. Identify any missing or irrelevant information you do not need to solve the problem. So we've got, I'm going to try to write this relatively quick. This is the problem that's in your book, so if you don't want to write it, don't feel like you have to. But I'm just going to write it out so we can underline stuff. So number 4 says, one day, Paul ran at a rate of 0.15 miles per minute for 40 minutes. The next day, Paul and Jen ran together at a rate of 0.16 miles per minute for 50 minutes. How far did Paul run altogether? I'll let y'all get that down and then we'll walk through what it's looking for. All right, so with this one, okay, what are we trying to solve for? Or like, what does it ultimately want?
How far Paul ran.
Okay, so how far he ran. And so since we have everything in miles per minute, okay, everything's in miles, so we're going to have our final units are in miles, okay. Now, it doesn't tell us that he ran 1 mile on day 1 and 2 miles on day 2 or something like that. So we're going to have to figure out how many miles he ran on day 1 and then how many he ran on day 2 using this distance traveled formula, okay? So our rate is going to be the 0.15 miles per minute for day 1 and 0.16 miles per minute for day 2. And then the time is going to be in minutes, okay? So we're going to be solving for D. So I would say when you're doing the problems, you could just highlight like what you're trying to solve for. These questions, I mean, they just want you to say like what information is either missing or relevant. And so basically what that's asking is it's saying to tell what you need to solve for. And so I would make a note that we are solving for distance. We're solving for distance. And just because there's not a whole lot of these problems, we actually will go ahead and solve this one. So we're going to use the D equals RT formula. So we're going to have to do that for day 1, and we're going to have to do that for day 2. So what I would do is I would do distance, and then I would put a little number 1 at the bottom right corner of the letter to tell you that you're doing day 1. So our rate is 0.15. And then our time was 40 minutes, so 0.15 times 40. Oops, why did I do that? So 0.15 times 40 is going to be, that's 600, move the decimal place over, so it's actually just going to be 6. Is that right? 6 miles? Oh, mile per minute. Never mind. Thinking miles per hour, and I'm like, whoa. So he did 6 miles on day 1. Okay. So then same thing for day 2. So we're going to have our distance 2 is this time it's 0.16 times 50 minutes. So 0.16 times 50. So that's going to end up being 8 miles when we multiply it out. So to talk about the total that he ran over both days, we just have to add those two together. So we're going to have our distance 1 plus our distance 2, which is 6 plus 8, which is 14 miles total is what he ran. Okay, now, this problem isn't actually asking you to solve this like we just did. All it's really asking for is that stuff right there. Okay, but there's not a ton of these in here, so I'm just trying to walk you through them as we go so that you, I mean, this one had all the information we needed. It wasn't missing anything that we had to have to be able to solve the problem. So we were able to solve that one. All right, let's see. This next one is one of them where they've intentionally made an error and they want you to find what their error is. Okay, so it says a town is fencing a rectangular field that is 200 feet long and 150 feet wide. At $10 per foot, how much will it cost to fence the field? So I'm going to draw a little picture here. So we have a rectangular field. So I'm going to just draw a rectangle. We're told that the long side is 200 feet, so that's going to be up here. The short side is 150 feet. Okay, now I can write them around. So this other long side is also 200 feet, and then this other width one is also 150 feet. So before I show you what they did, let's see what we do, and then let's compare to what they did, okay? So if I want to talk about a fence is going around the outside, okay? So it's the perimeter. So the formula for perimeter of a rectangle is what? Do you remember what that is? Or if you don't remember exactly, could you describe to me how you would find the perimeter? So that would be area, but it's close. Yeah, so that one, so we're going to add. So number 7 uses this information as well. And so number 7, you would need area. So you would need the length times width. So for the perimeter, we just add up all the sides. So P equals 200 plus 200 plus 150 plus 150. So our total perimeter then is what? Almost. Well, you need to add one more 200. I think you just added these 3. It was 500 plus 200. So 700 feet is the perimeter. Now, what does it want us to find? Like, what is our goal here with this problem?
How much will it cost for 2?
Yep. So I now know how many feet of fencing I need, okay? It tells me it's $10 per foot, okay? So 700 times $10 per foot, the units for feet are going to cancel, so we're going to have 700 times 10. Whoa. Wrong thing. So 700 feet times, I like to do it this way. When you get to Miss Marshall's class, well, next year, physical science, she will show you this way. So I'm just going to show you how to do the units so you've seen it before when you get there. So it's $10 per foot, so per 1 foot. So our units then cancel out. So we have feet go away, so that means the only units I'm left with are dollars. So we just multiply 700 times 10. When we're multiplying something by 10, we just add another 0 to whatever number we had. So this will be $7,000 is what it will cost to fence that field. So what they did is they had that P is equal to 200 plus 150 is equal to 350. And then they said that $10 times 350 feet is equal to $3,500. So the mistake that they made is they didn't add up all the sides. They only added 2 of the sides. So their error was that they only added 2 of the sides. These problems usually say to basically, describe and correct. So that was the describe part. We corrected it already. Okay, and you could have just said 700 times 10. You didn't have to write this box. I just wanted you to see it so that when you get to physical science next year, and you're doing conversions, you've at least seen this little box thing before for multiplication. Okay, so then the next one say to just state the formula that is needed to solve the problem. We don't need to solve it. So we're just going to write down what formula we would use to actually solve for what it says. So number 8, we have the temperature is 68 degrees Fahrenheit. What is the temperature in degrees Celsius? So if I'm given something in degrees Fahrenheit and I need it in degrees Celsius, which formula that we used would you, or that I, like out of the ones I gave you, would you use to solve that? Yep. So what is that formula? Yep. So that's all we would have to do. If we were going to solve it, okay, and like I said, you don't have to, but if we were going to solve it, all we would do is we would take this number, here, and we would plug it in for F. That's all we would do. So we would just take 68 minus 32 and then multiply it by 5/9, and that's how we would get our degrees Celsius. But this one just wants you to write the formula that's needed for it. All right, number 10 says find the area of a triangle with a base of 25 feet and a height of 8 feet. So, what am I trying to solve for here? Yeah, like what am I, like what is, yep. So I'm trying to find area of a triangle. Do y'all happen to know what the area of a triangle formula is? If not, it's okay. Comes more in geometry, so. Area of a triangle is 1/2 base times height. So in this case, all we would do is we would plug in this 25 for the base and 8 for the height, and that's how we would solve that if we were going to solve it. But it just wanted the formula. All right, just one more and then we'll basically be done with this section other than me giving you a few to do. Number 12, this one is a multiple choice problem, but it says a car travels at an average speed of 55 miles per hour. How many miles does the car travel in 2.5 hours? And then our answer options are 22 miles, 57.5 miles, 110 miles, or 137.5 miles. So the question for this one is, what are we trying to solve for? Yep. So how many miles does the car travel? Okay, is what we're looking for. And so which formula out of the ones that I gave you are we going to be using for this? So that's, whoops, I did it again. D equals RT. And so it wants to know how many miles the car traveled. So that means that I'm solving for distance. Okay, so this 55 miles per hour is my rate. Okay, and 2.5 hours is my time. So all I'm going to do is I'm going to plug in 55 here and 2.5 here, and then I'm going to multiply. So D equals 55 times 2.5. And then I can set that up to multiply. So that's going to be 25, carry the 2, 25 plus 2, 27. 0, it's 10, it's going to be 11, so then add 5, 7, 3, whoa, decided to disappear on me. So then we had one decimal place, so I'm going to move the decimal over 1, so 137.5 is how many miles the car traveled in 2.5 hours, so the answer is D. Any questions about any of these ones? Okay with these? It's more just the fact of setting them up, and then once you do that, you can plug in and check them. So, okay. So there's not, like I said, there's not a ton of problems in this section. So let's see, 3, 5. Well, I was gonna say do 7, but 7 is, we already solved 7 basically by doing 6, so never mind. 9 and 11. Now with 11, I'm just gonna make a note here really quick. It says at a rate of 5% per year. Okay, this is an interest problem. So the number that you've got to use, because your rate has to be a decimal, is we move the decimal place over 2 places to the left. So as a decimal, it's going to be 0.05. Okay, when you plug it into the formula. All right, and that's all you have to do.